In chapter 1, the first sections that we talked about explained the laws of exponents. And there's a few laws of exponents that we need to remember. The first one is when you're multiplying bases that are the same, you have to then add the exponents. Okay? When you're dividing bases that are the same, you have to subtract exponents. Okay. And then when you're dealing with coefficients, if it's a division problem, you also have to divide the coefficients. Whereas if it's a multiplication problem, you multiply coefficients. So coefficients get the operation that's happening in the problem, whereas the exponents get the rule. Okay. So if we look at number 1, tells us to simplify using the laws of exponents. Well, I noticed that this is a multiplication problem, and I have 2 coefficients, a 2 and a 3. And I know that because this is a multiplication problem, I am going to have to multiply those together. Then I take my x on my next letter, which would be x, and this is an x to the first power, to the first power, and to the first power. Since neither of them have any exponents, they are all imaginary ones. So this becomes x to the 1 plus 1 plus 1. And then once again, y to the, there are 1 plus 1. Never leave your answer in this form. Always simplify it. 2 times 3 is 6. X to the third power, y to the second power. 2 is very similar to that, so follow the same rules. If we look at 3, once again, I notice that there's multiplication in the problem, and since my bases are the same, I can add the exponents. X to the 3 plus 2 gives me x to the 5th power. Notice in number 4, when you're adding exponents, make sure that you put an imaginary 1. In 5, this is multiplication shown by parentheses. The process is the same though. You take the coefficients and you multiply them together. You take the exponents and you add them. And this would give me negative 8y to the 7th power. Okay, number 6 is the same process. Make sure you multiply the coefficients. Number 7, you're just dealing with different variables. So take my coefficients and multiply them. Take your exponents. There's a 2 for the x, and then there's a 1. And add those together. And then take your y's and add them as well. Make sure you always simplify your work. This gives you 12x to the 3rd power, y to the 6th power. Notice in number 9, number 10, and even 11, 12, and 13, you're dividing because of the division bar. The rule says that when you're dividing, you have to subtract exponents. So if I do number 9, I'm taking the numerator exponent and subtracting the denominator exponent, which gives me x to the 8th power. If we look at number 11 is a little bit different because my bases are all numbers. The process, however, is the same. So we take our coefficients, or our bases, and subtract the exponents. 2 to the 5 minus 3, 3 to the 4 minus 1, and 4 to the 6 minus 2. This gives me an answer of 2 to the 2nd power, 3 to the 3rd power, 4 to the 4th power. Okay. Looking at number 12, my coefficients are 27 and 3, and since this is a division problem, I am going to have to divide them. The number that goes into both 27 and 3 is 3. So I'm going to divide that top number and bottom number by 3. 27 divided by 3 is 9. 3 divided by 3 is 1. And now we go ahead and subtract your exponents. Numerator minus denominator. So this is 5 minus 2, y to the 6 minus 1. And then we can go ahead and simplify the problem. We don't need this division by 1 because it's understood that it will always be there. And I get 9x to the 3rd power, y to the 5th power. When it comes to a power, you multiply them. So this would be x to the 2 times 4. This is an exponent raised to an exponent, which gives me x to the 8th power. And in number 16, notice that you have to distribute the exponent to each of the bases separately. Make sure, though, if the coefficient is negative, that number goes into parentheses. So this becomes negative 2 to the 3rd power, a to the 2 times 3, b to the 1 times 3. And then we can go ahead and simplify. Negative 2 to the 3rd power is going to be negative 2 times negative 2 times negative 2, which gives me negative 8. A to the 6th power, b to the 3rd power.